I'm going to demonstrate the pairwise comparison web application, which is built using Spring Boot and Angular framework. Okay, so this is the landing page of pairwise comparison application. So once you click on this help section, we can see the number of options we have here. So first is like import your model, add node, change node, delete node, analysis. Okay, so by default our application loads with the root node, which has a value of 100, and since it doesn't have any parent, that's why we see this as empty here. Okay, let's add few nodes. Let's add A, B. We can see the two node got added. You can see the visualization once we click on the tree map. Let's add two more, C and D. So till now we have added 4 nodes under root, and we'll see the tree map here. The value got divided equally among each of the child of root node. Once we click on the tree map, it shows the visualization of the child nodes itself. Since we don't have any more nodes within child, so that's why I cannot click it here. Now let me add few nodes under the child. So let's add node B1 and B2 within parent B. Now we'll see, we'll click on it, and we see that we have added the node B1 and B2 within the child node B, and that's why we see the value got divided between is 12.5 and 12.5. So let me add few more nodes among C. This time we are going to add 4 nodes, C1, C2, C3 and C4. So now I can see like I have added quite a lot of nodes under child, and I can see like the high chart shows me like there are 4 nodes inside this child node. So once I click on the tree map, I can see the visualization that node B have 2 nodes, node C have 4 nodes under it, and the value got equally divided, that is 6.25, 6.25 among all of its child C1, C2, C3 and C4. So if I click on it, I can see a pretty good tree map of its child node. So this is a hierarchical level tree we have demonstrated. So the basic requirement of pairwise comparison is we must have 3 nodes within a parent to perform any kind of analysis. So here within B, I'll re-show it once more. We have only 2 nodes, B1 and B2. We don't have 3 nodes inside node B. And okay, so if I try to perform analysis on B node, I should receive an error like I have less than 3 nodes. Let's see. And yeah, I'm expecting an error. I got an error. Node must have at least 3 child. Okay, so that is expected. Great. Okay, now I want to delete a node. Let's say, let me first change the node name. So I want to rename the node. Let's rename it to B22 something. Let me change it. So I can see the B2 is changed to B22, and I can see this node B22 is updated here. Okay, and just to show you again, this node B22 is here again with the new name. Okay, now I want to analyze C node because C have 4 children. So I'll click on analysis, and this is my pairwise comparison matrix. So I'll just put some values. For now it's I'm just putting some random values for, and I think 3 will be fine. Yeah, and I'll click on max inconsistency. So I can see, so I got these 4 inconsistency from the upper triangular matrix. Okay, so ijk is nothing but the index in the formula created by the Professor Koczkodaj. So the formula states that the I value should be the index of I should be less than j, and the j index should be less than k. So that's why we can always see that the I is 0, and in the upper triangular matrix here. So above this is the diagonal in the upper triangular matrix. So when I is 0, j is 1, and k is 2, we'll calculate the Koczkodaj inconsistency indicator, and these are the values. So 2, 1, 4. Okay, so now we have this inconsistency weighted chart. So all this inconsistency has been showed in this weighted chart. So like 8.7 0.87 out of 100%, this has like huge weightage, like 35.7%. Then we have other inconsistency like 0.7 here, which has the weight of like 28.7% in whole of this inconsistency weight chart, and the rest is also demonstrated in the same way. So in the inconsistency histogram, we see that in what ranges the value lies, and based on that we have created a bell curve. So the value this 0.87 lies between these, and the rest is also demonstrated in the same way in the histogram. So now we are going to reduce this inconsistency because this is the highest inconsistency, 0.87 here we can see. Now let me reduce it. So we can see the inconsistency had been reduced greatly to 0.26. So as per Dr. Koczkodaj, if the inconsistency has been it's below with 0.33, then it's quite a good result. And we can see the inconsistency histogram, the reduced inconsistency histogram. So the new value has been highlighted here. We can see 18.2, 34.5%. So we can see the values is 0.19, 0.26, and 0.1. Okay. Now let's come back to the tree map again. So what we did it for C, right? So let me open C. Okay, so since we worked only on C, so you will see the value changes only for the C hierarchy. The rest will remain the same, will remain untouched. So if I click on it, you can see the 9.76, 8.6, and so on and so forth for the other nodes. The rest will remain the same, 25, 8, 12.5, 12.5. Okay, so this is overall the hierarchy. We have it. So there's one more button. We have it here, like this import your model. So we can import our models. So let me reset my this application first. So currently I have all this and this, so everything will be gone. So let me click, and here we go, and we can see everything got deleted, and this is my root node only. So if you don't know how to start, so we suggest you must download an example from here. So example downloaded. Let me open the example. Okay, this value doesn't make any difference, so I'll just put it 1, or I can put it even the same way I want. So let me change it to 4. Let's say 2, and let's say 7. Okay, and let me see. So this is example 2, 5. Yeah, this time let's do for 3 by 3 this time. Okay, because I didn't show for 3 by 3. Example 2, file got uploaded. We got the notification, file uploaded successfully. So we can see the 3 node got added. Okay, so since it's 3 only, so that's why we see that 33.33 is the division. Now we can see in our matrix we have the value 4, 2, 7, and here based on the upper triangle matrix, the lower is also calculated, which is expected. Now I click on max inconsistency. So I can see there is only one inconsistency, so that's why I will see only this 100% weightage it have 0.93%, and only one value which lies almost near to 1, okay, which is quite high because our threshold is 0.33. So I'm going to click on it, reduce inconsistency. Okay, and the value has been reduced to 0.09. Okay, we can see it in the histogram. Now the new value is 0.09, and here as well it's 0.09. This is still the inconsistency is still counted uh, because in from the upper right we calculate the inconsistency, but it's way below the threshold. So you will always see the inconsistency even after you calculated everything, but it is below the threshold. That's what the application is demonstrating. So 0.09, which is way lower than 0.33. Now we can download this result as well. So if I want to download this pairwise comparison matrix only, so I have this download button, and I can show you 1 second. Here we go. So we have this matrix. Let me close the earlier one and let me show the result. We can have the similar method. We can share it with anyone if you want. Now if I want to download the tree map result, so there is like value got updated 55.25, 33.29. Okay, this value. If I want to share these, just the value, not the tree map, so I can download the tree map values, and there we go. There we have the values. Okay, and let's say I don't want to download the values, I just want to share the charts. So I have the feature with me here, so whichever the format I prefer. Let me prefer PNG. Let me download PNG this time. So there we go. We can download the histogram and share with anyone we want. And a similar approach is with the tree map. Let me download the PDF this time. This we can see the PDF is downloaded. PDF, and we can see the pairwise comparison model. Pretty good. Yeah, and it does have one more feature which I didn't demonstrate it till now. So it has something like virus scanning feature. So let me download a virus from internet. It's a virus, and let me save it in a file. Pairwise. Oh, you might ask like why I'm downloading writing in the text file. I'll show you in a minute what's the problem here. So once I click on choose file, I can see that I can import only Microsoft Excel comma separated file, right? But there's a problem with all the UI application. Okay, just go and click on this, and you'll see always all files option in all the system, in all the application, that you can upload any file. Although the system it's upon the system implementation whether it want to reject or not. So let me click this sample version. Let me upload it. So here I got the response that file cannot be processed as it contains virus, because there is an external call to cloud immersive service which detects the file that someone have tried to upload a virus and try to bring down the whole application, or maybe he wants to steal some data from the server by uploading some virus and opening a specific port something. So it can be any script, so it's totally depend upon the cloud immersive service how it detects the virus. So we have implemented that feature. Okay, now let me show you one more thing. We go into desktop. Let me this time pick some random file. We will pick this untitled diagram. It's some random file. It should be, because the application accepts XML only, sorry, Excel only. So let me try this one. And this time the file format is not correct. That's why we got the error. So we have to upload a correct file to perform this action. Yeah. So that's all I have it for this presentation. Thank you.